Okay, hi and welcome to video notes 8.1 and 8.2. This is on exponents, properties of exponents. So we're going to get down to the basics first. We're going to go right through it. Just remember that the main topic of what this is, that it's a mathematician's shorthand. That's the first thing I kind of want to say. It's a little quote there, but it's just a way to write things simpler. That's all it is. So keep that in mind as we go through these notes and just thinking of condensing and writing very simply. I want you to do this investigation here as your homework. Make sure that you fill in the bottom three here and fill in these tables. So you're going to do that on your own and then we'll discuss it in class. So let's get to the actual properties of exponents. So an exponent, there's two main parts to an exponent. One, the base, which is the large number. It's usually bigger in size. So for example, you might see a 4. Looks like a number. It's bigger in size. The exponent's a smaller number. It's usually raised up to the right. That's where it should be. What these are, the base is the number that's being multiplied. The exponent tells you how many times it's being multiplied to itself. Okay, that's the key here. It's the same number. So if I have a 4 here, which is my base, and then I refer to, let's say, 3 times, it means it's going to be 4 times itself 3 times. That's what that actually means. Instead of writing out 4 times 4 times 4, which is a lot of work, and in general we don't write just a 3. They get much larger when you do some crazy calculations. We wouldn't want to write out 4 times itself 100 times. We'd write 4 to the 100th power, or 4 with an exponent of 100. So that's the concept of it being a shorthand notation. But there are rules to go with this under some of these, and that's what we're going to get to. So let's go ahead and practice here a bit. You can see that there's 2 times 2 times 2, which means it's going to be multiplied by itself 3 times, so the exponent becomes 3. The base is 2. It's the number being multiplied by itself 3 times. So 2 times 2 is 4, times another 2 is 8. So really, 2 cubed is 8. We would never really leave it as 2 cubed unless we were working with it to simplify it, and then when we went to find our final answer, we'd multiply it out and calculate it up. Okay, it's kind of how it goes. Here's 5 times itself 4 times, or 5 to the 4th. Put in a calculator, we can calculate that out. So let's do that real quick. Let me show you where that looks like. So here is your blank screen on your TI. Here's how you would enter 5 to the 4th. 5, and this is what we refer to as the caret key. In this operation, it puts it up. It looks like a power, so I type in 4. You may see in the Google Plus community, or if you don't have that aspect on your calculator, it might look like a little caret button. That's fine. And then you would hit enter, which would be 625. Now you're seeing how this works. So let's talk about another scenario. So we've got -3. Notice the parentheses are key here. We've got -3 times itself 1, 2, 3, 4, 5 times. So -3 to the 5th. Okay, that's easy. I can put that in my calculator. Great, let's find out what it is. But there's another aspect we have to take note of when we put in our calculator. It does have to have the parentheses. Why? Because if you don't, the exponent only belongs to the base it's directly next to. So when I do this, -3 to the 5th, we should find out that this stays a negative number. So this is equal to -243. Let's talk about that a bit more. So this is a -1 times a 3. I don't know if you noticed that. So really, oops, forgot to put the -1 in there. Really what this ends up being is it's 3 to the 5th times a -1, but there are 5 of them, right? So that means that if I multiply 2 negatives together, I get a positive. These 2 make a positive number. These 2 negatives make a positive number. And then there's 1 negative left over. So the result should be negative. And that's where that happens. So what you'll find out that odd powers, like the one in the example we just did, will always result in a negative number. Why? Because the exponent belongs to the 3, and then we just account for all the negatives that are floating out there. So this is the general rule of thumb. If it's an even power, we'll find out that it's a positive number. So if we change this to -3 to the 6th, we'd get a different number, but it would be a positive number in the end. Okay, so you can see the odds make negative numbers, again, dealing with a negative base, and evens make positive numbers. All right, so let's get to 2 actual properties. So that was how exponents work. Let's get to 2 actual properties here. The first property we're going to talk about is that anything raised to the 0 power equals 1. Real simple, not going to say any more about it, it's that easy. All right, so the second property we're going to talk about is a negative exponent. Negative's kind of like a direction. It's telling you to move it. And when we're talking about moving it, we're talking about moving from the denominator or the numerator to the denominator in fraction form, or vice versa is what you'll find out. So if I have a base with a negative exponent, I'm going to take its base and its exponent, and I'm going to move it. And you'll see me do this circle and arrow thing quite a bit. And if it's in the numerator, I move it to the denominator. Well, we need a placeholder. So 1 will stay in the numerator, and that whole base and exponent move to the denominator. Okay, so once you move its position, if it's the denominator to the numerator or the numerator to the denominator, you change its sign. Now this one here, just so you makes you feel a little better, is over 1. We wouldn't write it because it's just a placeholder. That makes it a fraction we don't need to see unless we want to. So if you ever move it out and there's nothing left, make sure you put a 1 there to hold the place of the position. If it's in the numerator, you don't have to write it. So switch its position and then change its sign. So let's see a couple of these. Here's a 0 property in action. Anything to the 0 property is 1, no matter what it is. Here's negative 1.02. Doesn't matter how crazy it is. It's just 1. Here's 3 to the negative 4th row. So now we're going to test the negative exponent property. So I'm going to take that particular base and that exponent, and I'm going to change its position. If it doesn't look like it's a fraction, it means it's in the numerator. So I'm going to move it out. 1's going to hold its position. Then I'm going to put 3 to the 4th in the denominator. Yes, we should multiply that 3/4 out, but we're just going to practice this property real quick. We'll do that in a minute. So here's a negative 8 to the negative 1 power. Well, don't forget negative 1 is really multiplied to the negative 8. And even though it's in parentheses, it still means that negative, if you don't remember about our fractions, can be in the numerator. It can be in, I don't know what I'm going to try to draw there. I can't draw it. I'll do it over here on the example. So it can be in the numerator, denominator, or in front. It doesn't change its position. So we can move the negative or we don't have to move the negative, I guess is what I'm getting at. So I'm going to take this and I'm going to move it to the denominator because it's in the numerator. So I'm going to put 8 under 1. And then I'm going to put the negative out front. It can go there, it can go here, it can go here. As long as you only do it once, it doesn't matter where it goes. It's all the same. So, and since it's to the exponent of 1, we wouldn't write it because we don't need to see a power of 1. It just means 8 times itself, which is 8. Or it doesn't even say once. It's just no extra multiplication there. So here is number 5, 7 to the negative 1 power. So really what you'll get used to doing is you'll just move the position of it, right? Move that base down 1 and move the exponent, make it positive. And so here's a negative 2. Again, the negative can sit out front. The 2 force, actually, I don't know why that's that way because that's not true. This means to do nothing. It actually stays negative 2 to the 4th power. It is not negative exponent. Okay, so here's part 2. We're going to work with the properties that we got, but we want to make one more note here. You'll read this this part here. It says that the exponents are only in the simplest form if there's only positive exponents. So that's kind of a rule. If you see a negative exponent, it means you have to address it. Okay, so let's take a look at number 9 here, and you can see here's an expression 4x times y to the negative 3rd power. Now this brings us to this point here. Exponents only apply to the base that it's directly above. So in this case, the only thing that's actually to this negative exponent, because remember negative exponents are telling us to move its position, that the y is the only one that's going to move. The 4 and the x will stay where it's at. So this ends up looking like 4x stays in the numerator, the y and the cube go to the denominator, and then we change its sign. So it becomes a positive 3. And that's how that goes. So here you can see that if it's in the denominator, we move it to the numerator. Remember, 1's just a placeholder there. Let's look at 11 real quick. Again, b is the only value here that's going to be moved because that exponent's only to b. If there were parentheses, that's a different scenario. So we would address that one differently. So 3 and a are going to stay in the numerator because there's no negative exponent. B is going to go to the denominator, and the 2 is going to become positive. All right, so here's the next part. A lot of times when we do these exponents, we're going to be evaluating, which means that we're going to plug some numbers in. And you can see here's a number for n minus 2, and here's what n equals negative 2, and w equals 5. But before we plug those in, and we could plug them in here, we'd be moving things with numbers in there. And it's generally more complicated if we have numbers because we might need start some calculations that we shouldn't. So it's better if we go ahead and clean it up, do these two properties, the 0 property and the negative exponent property, those are the only two that we know right now, and then plug in and evaluate. So that's what we're going to do. So if we look at that, there's actually 2 things to clean up here. One is the n, it has a negative exponent, so it's going to move, and then the 0, anything to the 0 power is going to turn into 1. So we've got 2 movements. W to the 0, which stays in the numerator, is going to turn into 1. And then the n here is going to move to the denominator, and that 3 is going to become positive. Now we'll evaluate. So we're going to go ahead and plug in that negative 2. I'm going to use parentheses because when we substitute, we use parentheses. And what that means is I've got a negative 2 times itself 3 times. We have to figure out what that is. You'll eventually memorize that 2 times itself 3 times is 8. You'll actually just memorize it. You'll do it so much. So the numerator's 1. But what about this negative? We talked about that. Here's an odd exponent, a negative base. We remember, or you should remember, that that means it's going to be a negative solution in the end. If it was an even number, it would become positive. Which brings me to question 15. You'll look that it's very similar to this one. There's n in the denominator. It's a 4, right? Here's 1 over n to the cubed. So they're very similar, right? You can see this almost the same here. We plug in, go ahead and evaluate. What we find out is that this one's to the even power. This one's to the odd power. So this one, when it's done and evaluated, will be a positive number. Okay? Well, what's n, or what's negative 2 to the 4th? Well, if negative 2 to the 3rd is negative 8, we multiply that by another negative 2, it's going to be positive 16. Okay, so now let's talk about scientific notation. Scientific notation falls in this category because it deals with exponents and their rules. Scientific notation is another shorthand. One thing to note right here, though, is that I need to change the notes. Notice that that is not included at 10, right? So it's 1 included between 10. What does that mean? That this first value in scientific notation, which you should be somewhat familiar with, has to fall between 1 and 10. It can be 1, it can't be 10. And what this is a way to write super large numbers. So if you look at 20 here, you can see that 20 is a really large number, and if I was doing a calculation and had to write that large number, 56,900, or 56, that's not even written the right way. It's like it's short of 0. We'll actually add a 0 there. So 56,900,000. We wouldn't want to write that number a bunch of times. And if it was even a larger number, when we deal with some different things, that we wouldn't want to write those either. So it's a way to compress a number, make it look a little more complicated, but much easier to work with. So here's the rule of this. All right. If you have, let me start this way. If the decimal gets moved to the left, right, this big arrow here, your exponent should be larger on the scale. So if it's negative, it gets more positive, or less negative, in that sense. If the decimal goes to the right, your exponent's number should get smaller, or it should get more negative. Okay. So that's your general rule. So let's go ahead and attempt to do some of these here. And again, these are divisions of 10 or multiplications of 10 is what we're doing with. So that's why it's a decimal move, just to kind of go back and reiterate that. So we're multiplying by 10 or we're dividing by 10. That's why the decimal is moving to the left or the right. So if we look at this first one, is it in scientific notation? Well, yes, it is. Why is it? Because 3.42 is between 1 and 10. So it's perfectly fine for scientific notation. Is 18 in scientific notation? No. 52 is greater than 10. Nope. That's larger. Okay, if we look at the last one, 0.04 times 10 to the negative 5th, 0.04 is smaller than 1. So no, this one's not. It's smaller than 1. So those are just looking at if it's scientific notation or not. Let's talk about writing some in scientific notation. So here's a number greater than 1. Here's a number smaller than 1. We'll do one of each. So if we look at this and remember our rules, I'll leave it up on the screen. I'm going to be taking this decimal, and I need to make this 56,900,000. I need to make it between 1 and 10. So I'm going to move the decimal place. Let me change my color. I'm going to move the decimal place 1, 2, 3, 4, 5, 6, 7 times. So if I move that decimal 7 times, I'm going to end up with 5.69. Those zeros are going to be accounted for by factors of 10. So if I want to make this decimal go back to where it was, or if I'm following my rule here, right, I moved the decimal to the left, so my exponent should go up, so it should be a positive 7, because right now we didn't have anything. It'd be times 10 to the 0 power. So we moved it 7 places to the left, it should go up by 7. There's your scientific notation. So here's the opposite of it, I guess I would say. We're going to take this number, and you can see that I need to get it. 0.00985 is below 1, so I need to get it between 1 and 10. So I'm going to move it 1, 2, 3 times, and what I end up with is 9.85, right? And I moved it 3 times to the right. So if my decimal goes to the right, my exponent should go down. Since we didn't start with a decimal, or times 10 to the 0, because it wasn't in scientific notation, I need to go down 3, so it'll go to a negative 3. It's okay to have those as negatives, by the way. All right, so let's take a look at this. This is, these are already done, so it says write each one in standard notation. So it's in scientific notation. You can see 1.55 times 10 to the 6th, right? Which, if we go back to our rule, if it's to the 6th power, right, it means that it was a large number than when it started, because it's a positive number. So we should go back to a large number. So generally, if they're positive, that means a large number, and generally, if it's a negative, it means a very small number. That's the rule of thumb with scientific notation. So looking at this being a positive 6, it tells me that I need to have a large number or move the decimal back to the right. Okay? So if we move that back 6 times, 1, 2, 3, 4, 5, 6, you'll get that number there, 1,550,000 Kelvin is what that represents. And then here's one a little bit different, the opposite way, right? So it's 2 times 10 to the negative 11th. Again, a negative number tells you that it's a very small number and that we need to move it back to the left. So we take the decimal. Sometimes you don't get to see it. It would be right behind it, or 2.0 if you will, and you're going to move that decimal 11 times to the left. You can see I did that here, 11 times. So, and I just rewrote it a little bit neater. We wouldn't want to write this number multiple times. That's why this is much handier to keep it as. All right, so there's your notes on exponents. There's your homework on the bottom. Don't forget to go back to page 1 and do this investigation so you can kind of see what happens with exponents a little bit more, especially with the negative part. That's what you're looking at here. Okay, we'll see you in class.